Section 4.3b. Next group of identities are the Pythagorean identities. All of these identities are based on knowing this identity here. If you know that sine squared plus cosine squared equals 1, you should be able to get each of the other identities. Obviously, if we go down this column, pretty easy to see how that we get sine squared is 1 minus cosine squared, just using this top equation. And if we solve that top one for cosine squared, it's 1 minus sine squared. So that's given how you get those two. Now, to get to the next group of 3 in the middle column, if I take this function, sine squared plus cosine squared equals 1, and I multiply it by 1 over cosine squared. Distribute that through. We get sine squared over cosine squared. Well, we know sine over cosine is tangent squared. 1 over cosine squared times cosine squared is 1. And on the other side, 1 over cosine squared times 1 is 1 over cosine squared. And 1 over cosine we know is secant squared. That then becomes our top identity right here. Solving for various things here. If we solve this top one for tangent squared, we get tangent squared equals secant squared minus 1. Or we can get all the functions on one side, subtract the tangent squared over, and secant squared minus tangent squared equals 1. So once you know the top one, you should know those 3. Likewise, we can take our original and multiply by 1 over sine squared. So again, take the sine squared plus cosine squared equals 1. Distribute 1 over sine squared through. 1 over sine squared times sine squared is just 1. 1 over sine squared times cosine squared is cosine squared over sine squared, which is cotangent squared. And 1 over sine squared times 1 is 1 over sine squared, which is cosecant squared. And then this becomes our top identity here. 1 plus cotangent squared equals cosecant squared. Manipulate that equation to get the bottom 3. So if you know that sine squared plus cosine squared equals 1, you should know all of those Pythagorean identities. Use identities to verify each equation is true. And this is kind of a brief introduction. We're not going to do a lot with this at this time, but we will do quite a bit with it in Chapter 5 at the start of second semester. For verifying that the identity is true, we work on one side of the equation. You'll have more of a checklist in Chapter 5. We're not going to get, like I said, in too much detail at this point. So I need to work down the left side of this equation so that we can make it equal to the right side. One of those things in the checklist, if you don't have any obvious place to start, you're going to change everything to sine and cosine. So cosecant, we know is the same as 1 over sine x. Tangent is the same as sine x over cosine x. Now when I multiply these together, what's going to happen to the sine x's? They cancel. I'm left with 1 over cosine, and I know from our reciprocal identity that 1 over cosine is the same as secant, which is what we needed to show. Letter B. There should be a pretty obvious first step here. We have conjugate pairs here in our two binomials. So let's multiply those together. Remember when we have conjugate pairs? First thing squared minus the second thing squared. And now anytime you see trig functions squared, you should automatically be thinking of Pythagorean identities. The Pythagorean identities is what relates trig functions that are squared. Cosecant squared minus cotangent squared. If you look at your previous slide here, cosecant squared minus cotangent squared is just equal to 1. Letter C. The left side here, we're going to separate the fractions. So this is tangent A over tangent A plus cotangent A over tangent A. First one, tangent A over tangent A is just 1. If we keep an eye on what we're trying to show here, we need to show that this is equal to cosecant squared. If we look at our Pythagorean identities, cosecant squared is associated with cotangent squared. So that's going to help us get our next step here. We want cotangent. We do not want tangent. Well, how can I rewrite tangent in terms of cotangent? That's 1 over cotangent. Multiply up by the reciprocal. We get 1 plus cotangent squared. And now if you look at your identities, 1 plus cotangent squared is cosecant squared, which is what we needed to show. Again, there's going to be a couple of those in the homework. It's just a brief introduction to what we're going to be covering much more in depth next chapter in section 5.2. Find x without using a calculator. We're told that x has to be between 0 and 90, so we know once again that we're dealing with quadrant 1. There's our angle x that we're looking for. We know the cosine of that angle is root 2 over 2, so that's adjacent over hypotenuse. That, however, is not a triangle that you recognize. So anytime that you have a triangle that isn't recognizable, in other words, it's not your 30-60-90 triangle, and it's not your 45-45-90 triangle, it's probably because this has been rationalized. So we're going to derationalize it. The way that you derationalize is the exact same way that you rationalize. You multiply by the radical over itself. We get 1 over root 2. Now when I go adjacent over hypotenuse, you should recognize that triangle as being 45-45-90. So x is going to be 45 degrees. Letter B. Tangent is opposite over adjacent. Right away, that should be recognizable. That also is going to be a 45-degree triangle or angle. Letter C, cotangent, root 3 over 3. Cotangent is the reciprocal of tangent. So this would be adjacent over opposite, not something you recognize, derationalize. We get 1 over root 3. And now when I go adjacent over opposite, you should recognize that. And you should recognize that this angle x, since root 3 is across from it, has to be 60 degrees. Last one, D. Secant, we know, is the reciprocal of cosine. So that's going to be hypotenuse over adjacent. Should recognize that triangle as being a 45-45-90. So once again, x is going to be 45 degrees. Using your right triangle trigonometry here, we know a 50-degree angle. We're looking for the side opposite. We know the hypotenuse, opposite and hypotenuse related by sine. So y is going to equal 15 times the sine of 50. That's what you're going to plug into your calculator. Make sure you're in the correct mode. Remember, anytime you hit sine, cosine, or tangent, you always must check mode. In this case, we need to be in degree mode. We're punching in 15 times the sine of 50. 11.491. Letter B, we know a 60-degree angle. We're looking for side x. We know the side adjacent, and we're looking for the hypotenuse. Those two are related by cosine. Cosine of 60 equals adjacent over hypotenuse. Solve for x. X is going to be 12 divided by the cosine of 60. Plug that into your calculator. 12 divided by cosine 60. We get 24.